This video will be practice on triple integrals. So, I assume you know how to set up triple integrals now and how to solve double integrals. And triple integrals are extraordinarily similar to how you would solve a double integral. You would just plug things in, set the bounds on now there's a z value for your triple integral, but you would just set bounds just like how you would in a double integral. So the first question will be triple integral with our function being x plus y plus z of dv, and the bounds for x will be from 0 to 1. The bound for y will be from 0 to 2, and the bound for z will be from 0 to 3. Now that we have that sorted out, all we have to do is just write down our function, turn dv into anything that you want. You can turn it to dx, dy, dz. Order of integration does not matter. And since we're integrating with respect to x first, you want to put the x bounds on the first integral. Next, we're integrating with respect to y, so you want to put the y bounds on the second integral. And the last thing we're integrating with respect to is z. So you want to put the z bounds on the last integral. Now that we have that all sorted out, all we have to do is solve for this integral. So how do you solve for this? First thing I like to do, I like to just separate everything from each other, less distracting, and just have the d, and just have the first integral by itself with the bound and the little d thing at the end here, whatever it's called. Hopefully, maybe someone in the comment section knows, and please comment that if you do know. But now that we can solve for this, we're integrating with respect to z with the x, and since y and z are treated as constants here, we can actually write this equation as x squared over 2 using power rule plus y times x plus z times x. And our bounds will be from 0 to 1 equal to x. If we plug in 1 and 0 here, 0 cancels everything out if we plug in 0 to x. So all we need to do is worry about the 1 value up here. If we plug in 1, you get 1/2 plus y plus z. Okay, now we solve for the next integral. Our bounds from 0 to 2. And now our new function is 1/2 plus y plus z dy. So we're integrating with respect to y now. Okay, 1/2 is a constant, so we multiply it by y. Y is a function that we can use power rule on. And z is treated as a constant, so you just multiply z by y when you're finding the integral. Now our bounds are from 0 to 2, so equal to y. We plug in 2 because 0 cancels everything out. So all we need to do is worry about the 2 bound. If we plug in 2 for everything, you get 1 plus 2 plus 2z, which is also equal to 3 plus 2z. So now we have the last function. And with the last integral, our bounds from 0 to 3, we have the function we found down here. Let's actually underline these to make it so that you guys know what I'm looking at. And if we continue this, integrating with respect to z, 3 is a constant, so you get 3z plus z squared from 0 to 3 for z. And 0 cancels everything out, so all we have to do is worry about the 3. So we just plug in 3 into everything, we get 9 plus 9, which is equal to 18, which is our answer for this triple integral. Now, this problem is a little more tricky because now the order of integration somewhat matters. You can change your bounds, but in the end, you're going to have to follow some format for this problem. And that format will result in a constant being at the end of your answer. So previously, the answer was 18, right? and 18 is a constant. We get a constant whenever you solve for an integral. You don't want some function like x, like you don't want to solve an integral and you get x squared plus y squared. What will that give you? What will that tell you? Right? But for this triple integral, you have to set it up a somewhat specific way. And that way is integrating with respect to z first. Because when you integrate with respect to z, you plug into your function, so you replace all the z values in your function with x and y values. And you're left with just a function of x and y. And now you have that function. You have to integrate with respect to y, and that results in just x being inside of your function. I'll show you what that means right now. It's easier to show you than explaining it. But your bounds for z are x and y and 0. Your bounds for y are for 0 and x. Your bounds for x are 0 and 1. So I'm going to have my function x, y, z. I'm integrating with respect to z, y, and x. Now that we set up this integral, what can we do? Well, we're integrating with respect to z first. So let's go ahead and write that integral down. So with respect to z is x, y, z, dz. And then you use power rule. So you get something like this for x, y equal to z. Now if you plug in 0, again, you just get 0. So for the entire equation. So give it a round of applause with 0, because they're very, very helpful when you see stuff in integrals. Wait, I'm gonna take a bite of this Frito chili cheese. Flavored chips. Okay, let's plug in for x and y. Well, when we plug in for x and y, we get xy squared, you can z squared here, over 2. If we simplify all this, we get x to the power 3, y to the power 3 over 2. Okay, that is our next function. Now, we integrate with respect to y, because that is the next thing we integrate with after integrating with respect to z. Our bounds for y are 0 and x. And now, we have to move our function down into the new integral. So dy, if we integrate with respect to y, you will get x to the power 3, y to the power 4 over 8. And your bounds are 0 and x. So see what I meant before. When you plug in x and y for your z values, all you get is some function of xy. And that's this right here. Right here. Now when you plug in x into y, right, what we're about to do right now, you get some function of x. So again, 0 cancels everything out. So this becomes x to the power 7 over 8. Now we solve for the last integral, 0 to 1. So x to the power 7 over 8 with respect to x is equal to x to the power of 8 over 64. From 0, 1, the x bounds. Let's actually underline this function for consistency. If you plug in 0, again, everything cancels out. So if you plug in 1, 1 to the power of 8 is just 1. So your answer is 64. Man, my pen, like normally this pen feels like weird. The sensitivity feels super weird. But today, ooh, feels clean, man. Also, I swear, there's at least one person, one of you guys, that watches all of my videos. Or like is like a returning viewer or something. Because I see that you're liking it. You're like hitting the like button. I appreciate that, by the way. Because I actually enjoy YouTube. It's quite fun. But, so, any support is thanked. And maybe, I don't know. Eventually, after I'm a senior or something like that, I'll make even more videos. But, at this point, I'm at 38 subscribers. So, I'll keep making videos, but that's enough of the yapping. Let's continue on with the question. So let's set up this triple integral. Your function now is just e to the power of x. And let's not write the d yet. So, as you can tell before, Previous question, order of integration kind of mattered. It just made it easier. But what you can tell here is that when the bounds for z are 0 and y, therefore we plug in y and 0 into our function whenever we integrate with respect to z. So when we do, we're going to get, again, some function of x and y. And at the end, we want a constant. And then next, we integrate with respect to y, because we can actually plug in for x, and we just get a function of x. So we get calc 1, kind of a calc 1 integral at the end. All we have to do is plug in ln of 2. So at the end, we wanted some constant, which is this, in this case. So the last thing we integrate is our, with respect to x. So let's integrate with respect to z, as we said, with respect to y, and then respect to x. Our bounds for z are 0 and y. Bounds for y are 0 and x, and our bounds for x is 0 and ln of 2. Okay. Start the problem with integrating with respect to z. So e to the power of x is a constant in this case, because we are integrating with respect to z. Well, it's treated as a constant, it's not a constant. So what we get is e to the power of x, 0, y is equal to z. And once we input y into here, we get y e to the power of x. And also, 0 is going to make things, everything else turn to 0 if you plug it into z. So this is our new function here. Let's continue on with this problem. Now we integrate with respect to y. And we use the new function that we got after integrating with respect to z. Underline it. Make sure you guys can see. And when you integrate this, it's power rule. Again, e to the power of x treated as a constant. So y squared over 2 times e to the power of x will be our new integral. Or the answer for our integral. X is equal to y. These are our bounds. If we plug in x for y, we get x squared over 2 e to the power of x. If we plug in 0 for y, everything turns to 0, so we can ignore that. Now this is our new integrand. Ooh, this was a hefty one because it requires integration by parts. Maybe you guys remember that. I'll do a quick recap on it. But the format for integration by parts is u v minus the integral of v du. Let's make this more of a v du is just the answer for your integral. And all you need to do is find what u is and find what dv is. And then find du and dv in order to solve for everything here. So that's just a quick little crash course on integration by parts. But when we try to integrate this, you get equals dx. So now we have to pick there's two functions in this equation, so we have to use integration by parts. Matter of fact, make this a little easier. You can factor out the 1/2 so that we don't have to deal with anything that has more fractions. So it's just x squared. So we pick a u and we pick a dv. I'm picking u as x squared because it's easier to derive, and not easier to derive. I'm picking u because for dv you need to find v, which means we need to integrate that function. So actually I'll pick x e to the power of x for dv because it's easier to integrate e to the power of x because e to the power of x, so integral is just itself. And the derivative of x squared is 2x. So now we have that. Our new answer for this integral will be u and v. So x squared e to the x minus the integral of v e to the x times du, which is just 2x. So actually let's put 2x in the front here. 2x e to the x dx. Technically there's a dx here. I didn't write it. Now that we have this, again, we need to use integration by parts. So, u dv is equal to du and v. U here, in this case, is 2x. Makes it easier. Derivative of 2x is just 2. And e to the x is dv again, because finding the integral of e to the power of x is easier. So now that we have this, all I have to do, again, plug everything in. We have the beginning portion of our integral still the same, because we are just using integration by parts on this part of the integral. But let's put it in parentheses. We got uv, so we have 2x e to the x minus the integral of v du. So v is e to the x, and du is just 2. So we have the integral of 2 e to the x dx. And we can actually solve for this, because the integral of 2 times e to the x is just 2 times e to the x. So our final integral is x squared e to the x minus 2x e to the x plus 2e to the x times 1/2. Don't forget the 1/2 out here. So everything is times 1/2, which results in the 2's being canceled out here. And now that we have our final integral, what did I just do? Now that we have the final integral, and let's move all of this actually. Why is it doing that? Let's move all this here. This is our answer. We have our bounds from 0 to ln for x. We plug in ln of 2, we got natural log of 2 squared. We get e to the natural log of 2, which is just equal to 2, divided by 2, and then these cancel out. So actually, let's write everything down first. And we get ln of 2, right, times e to the x, which is just e to the ln of 2, and e to the ln of 2 again is just 2. So we get this times 2 plus ln of 2, which is just 2. And we didn't finish it yet. I'm just simplifying everything, because we still need to plug in for 0 here. Yes, sometimes, especially for exponential functions, never ever forget the 0. Typically, in our previous problems, we forgot the 0. This one, don't do that. We plug in 0 into this part of the equation here. Let's actually put minus. You get just 0. We plug in 0 for x here, you just get another 0. What if we plug in 0 for e to the power of x? Well, you get 1. You get actually plus 1. So as a result, you just get plus 1 when you plug in 0, or technically minus 1. If we simplify everything here, you get ln 2 to the power of 2 minus 2 ln 2 plus 1. So this is our answer for the integral up top here. So for this last problem, I guess you can already tell, if you have some form of math sense, that this question is going to be so fucking tedious. When I was doing this before the video, I was like, yo, this shit is taking so long. So I'll try to compress this for you TikTok enjoyers. But again, we're integrating with respect to z, then with respect to y, then with respect to x for the previous reasons stated. So our z bounds are x plus y. Our y bounds are square root of x, and our y bounds is square root of x and 0, and our x bounds are 0 and 1. Our function is x squared plus y squared, and we're integrating with respect to z, with respect to y, then with respect to x. It's supposed to be parentheses around here, but I'll leave that out because I'm gonna need a lot of space for this problem. I don't know. I think you guys already know what I'm talking about, so I'm not gonna put the parentheses there. Okay, let's integrate with respect to z first. So z bounds are 0 and x plus y. Notice how none of these are dependent on z. So we're treating x squared and y squared as a constant. So we integrate this with respect to z. You get zx squared plus zy squared. And we're plugging in x plus y here. So when you plug in x plus y here, you get x to the power 3 plus y times x squared plus what's the next one? Plus x times y squared plus y cubed. Okay, this is now our new integrand when we're integrating with respect to y. So let's integrate with respect to y. Bounds are 0 and square root x. Rewrite our function that we solved for before, our integrand that we solved for before. Integrating with respect to y. Wait. I need to use these tools more often. Oh, that's a straight line. No, don't change the color. Alright. Integrate with respect to y. We get this guy, this monster right here. And then our bounds are from 0 and square root x. 0 turns everything into 0, so we can ignore it once again. But we need a new line for this because of how big and massive this problem is. Get your head out the gutter. Okay. Technically, square root of x is x to the power of 1/2. Okay? So, when we plug in, we substitute square root of x into all our y values. We're just treated as x to the power of 1/2. So x squared here just cancels out to turn to x over 2, x to the times 2, power of 2, plus x and y to the power of 3. So this is technically x times y to, x to the power of 3 over 2, using some basic algebra, and our final form will be x to the power of 2 over 4. So this is our new integrand. Hopefully we'll have enough space for this guy. And if we simplify everything, you get something that looks a lot better than this. But let's try simplifying. This is x 7 to the power of 7 over 2, because when you multiply exponents, you add the exponents together. Multiply exponents with the same base, you add the exponents together. So 3 plus 1/2 is 7 over 2. And again, we add the exponents together, so you get x over 3, x to the power of 3 over 2, plus x to the power of 5 over 2 over 3, plus x to the power of 2 over 4 of dx. We integrate everything, and then we get 2 over 9, x to the power of 9 over 2, using power rule for basically everything. X to the power of 4 over 8, and x to the power of 7 over 2, x to the power of 7 over 2 for, what is this, 2 over 21. I think that's what I had in my notes. Let me check. Yes, it was. And the last one, x squared over 4, is x to the power of 3 over 12. 4 are bounds, 0 and 1. Underline for consistency. Sorry. Underline this integrand to here. Oh, wait. This is the integrand that we plug into the next integral. There you go. And if we plug in 1 for everything, let's draw an arrow because you ran out of space. You get something that looks like this, since 1 to the power of anything is just 1. all we have to do is just get the coefficient. So 2 over 9 plus 1 over 8 plus 2 over 21 plus 1 over 12. And this is just equal to, if you want to simplify all of it, honestly most math teachers are fine with you just once you find the constant. And once you have some like constants, it's fine. But if you want to simplify this, it's 265 over 504. So if you have any questions about integrating using triple integrals, put it down in the comment section. Have a wonderful day.